Alright, today we're going to be talking about actually two things in your kind of lesson part because they're both going to be in your homework. The first thing we're going to talk about is how to add and subtract what are called like fractions, which means they have the same denominator. Then after that I'll talk a little about how to add and subtract unlike fractions, meaning they have different denominators. Okay, so the like fractions is pretty straightforward. Hopefully we're okay with this part here. So a like fraction, if you recall, basically because the fractions have the same denominator, we can keep the denominator exactly the same and simply add the numbers in the numerator. 3 plus 1 becomes 4. Okay? If a subtraction, the same is true. We keep the same denominator because they already are the same. Keep that there and we just do the math. This becomes 2 minus 1. We do 2 minus 1 for 1. So again, a couple quick examples here. Okay, if I have the denominators the same, okay, these are like fractions, and I just keep that denominator as an 8, and then I do the math. The math that's left is to do 5 plus 1. Well, 5 plus 1 is 6. It does say to write in simplest form. So that means I need to just think about reducing. Okay, to reduce is another step. It's thinking about what number do they both have in common through multiplication. So I know that I could divide this by 2. I could divide this by 2, and if I do the same thing at top and bottom, I'm reducing it. 6 divided by 2 is 3, and 8 divided by 2 is 4, and I don't see anything these have in common that I could reduce any further, so the simplest form would be 3/4. Alright, number 3. Alright, now this is where it gets a little tricky because we have this negative sign in front, which means this is a negative 1/4 plus a positive 3/4. So let's think this carefully through. 4 and 4, that's our denominator. No big deal. But let's rewrite this. This becomes actually negative 1 plus 3. I'm going to keep the negative with the 1. Negative 1 plus 3. So now I have to go back to my lesson and remember about how we add and subtract integers, right? If the signs are different, negative, positive, we find the difference and keep the greater sign, or the greater absolute value. So the difference between 3 and 2 is 3 minus 1, which is equal to 2. The 3 minus 1 is 2. Which one has a greater absolute value? The 3 or the 1? Negative 1. Well, the 3 does, so it's going to stay positive. So the number on top is 2, number on the bottom is still 4, and then I can reduce this by dividing this by 2, dividing this by 2, and ending up with 1/2. Okay? Alright. So that's how that looks. If you think about that one as a model, for example, let's say that I had 3/4. So let's go with 3/4. So here's 3/4. So I have 1, 2, and 3. Right? That's 3 out of the 4 sections right there. That's 3/4. 3/4. And what am I doing? I'm taking away 1/4. So if I take away this one, how much is left? Well, this much is left. So that much is left is what? It's 2 out of 1, 2, 3, 4. But if you look at the picture, what is that really? Well, it's about half, right? So that's how you reduce that down there. Okay, 5 straightforward. We have a same denominator, so it stays 9. 5 plus 5 is what? It's 10. So is that simplest form? No, because if the number on top is greater than the number on the bottom, then we have to reduce. That means that 9 goes into there one time. Okay, there's one whole 9 inside of that one. So I can take that one out and put it out here because this is really going to be, this is like 9/9. Let's write it back that way, in fact. Let's do it like this. This can be written as 9/9 plus 1/9. Okay, much the same way as this 5/5, same thing. But when you look at it this way, 9 plus 1 is 10. Well, what is 9/9? 9/9 is 1, plus 1/9 is simply 1/9. So I can turn this improper fraction into a mixed number like so. Straightforward, denominator is 10, good to go. Add, 3 plus 1 is 4. I'm going to need to simplify, divide by 2, divide by 2. 4 divided by 2 is 2, 10 divided by 2 is 5, and I'm set right there. Okay, enough of those. That's for the same denominator, but you can see there's a few other little things in here you have to be able to do. Simplify, You'll have to be able to work with positive and negative integers. You're going to have to simplify it if it is an improper fraction and turn it into a mixed number there, and simplify. Okay? Now these are ones that are like fractions. We're going to do the same stuff here with unlike fractions, but before you can work with an unlike fraction, you have to be able to have a common denominator. If they have different denominators, you have to make sure there's a common denominator. The easiest way to do that is to find the least common denominator. Okay, and we'll talk about that in just a second here. There's lots of common denominators that are possible, but you want to find the smallest one. Otherwise, your numbers get huge. Okay, once you have the least common denominator, you'll use that to then start adding and subtracting and figuring that out. Okay, so let's look at a couple examples. I'm going to ignore the model one for right now. Here's one that uses the least common denominator as an example. You can see we have 2/3 plus 1/4. The denominators are different. Okay, so one of the easiest way to do the denominator is basically to take the denominator 1 and the 2 really, and you're going to multiply them together, so to speak, so that 3 times 4 is 12 to get your denominator. But you want to also make sure that you multiply the denominator to the opposite numerator, like so. So let's write it like this way. It's like thinking I have 2/3 plus 1/4. Okay, so I know that this times this is going to give me 12. That's my denominator I'm going to end up with. So this is really multiplying this by 4 times 4. That's how I got the 12 right there. And I'm going to multiply this one as 3 times 3. In doing this, 4 over 4 is 1, 3 over 3 is 1, so nothing is changing, with the exception of my denominator is changing here, so that becomes 12 over 12. Let's rewrite this here. Okay, this becomes 4 times 2 over 12 plus 1 times 3 over 12. If I just don't multiply the top part together real quick. So 4 times 2 is 8 over 12 plus 1 times 3 is 3 over 12. And now we simply have a common denominator. Like fractions, we add 8 plus 3 is 11 over 12, and we've solved it. Definitely a lot more steps involved if you don't have a common denominator. In this case, 3 and 4, the least common denominator is 12, and you get that by multiplying them together. But be careful that you don't do that for all of them, because if you multiply the two denominators together, sometimes they're large numbers and you don't want to work with that, so you might want to think that through. Let's do a couple examples just real quick to make sure we're okay with this. Alright, so let's take a look at this first one. We have 1/2 plus 3/4, so that's 1/2 plus 3/4. My common denominator in this case here, I can see that 2 already has something common with 4. So if I multiply this side, this fraction, by 2 over 2, what happens to this? This becomes a 4, and 2 times 1 is 2. So now I can ignore this part because I've changed 1/2 into 2/4, and now that I have a common denominator, I can add. The denominator stays the same, 4, 4, 4, and I do 2 plus 3 is 5. But should I stop there? Nope, because my numerator is too big. I could think about this as being what? This is like 4 over 4 plus 1 over 4, because 4 plus 1 is 5. Anything changing here from that one? Nope, just breaking apart the 5 so you can see it a little bit better. 4 over 4 becomes what? 1 and 1/4. So now I've turned the improper into a mixed number. Look at number 3. We have 7 over 15 plus negative 5 over 6. All these extra little things happening, huh? Okay, so I want to find a common denominator. This is an example where you probably don't want to do 15 times 6. That's going to get big, okay? Now I know 6 doesn't go into 15, but what I ask myself is, okay, well, what's 15 times 2? Let's go to the next one up for the big number. 15 times 2 is 30. Well, does 30 have anything in common with 6? Sure it does. 6 times 5 is 30. So my least common denominator is going to be 30. So again, how do I get to 30 from 15? I multiply it by 2. So I'll multiply top and bottom by 2. Over here, how do I get from 6 to 30? I multiply it by 5. So I'll multiply the top and bottom of this side by 5. Because why? 2 over 2 is 1, 5 over 5 is 1, not a big deal. So the denominator's here. 15 times 2 is 30. 7 times 2 is 14. And we're going to add 6 times 5 is 30 over 5 times 5 is 25, and it's a negative 25. Why negative? Because that didn't change. We kept it negative. We're not worrying about that integer. Okay. Now I have denominators the same, so that's going to be a 30 on the bottom, and I have 14 plus a negative 25. So now I'm back to the previous lesson, where if I'm adding a negative number here, the signs are different, so I'm going to find the difference. 25 minus 14. 5 minus 4 is 1. 2 minus 1 is 1. Which one has a greater absolute value? Negative 25 or 14? Negative 25 does. So it's going to stay negative 11 over 30. So again, lots of steps with these, and so lots of places where you could make an error. But again, fractions are not bad. Fractions are your friend, like we said before. They're 1/3 of your friend because of the F and the R. They're right there. They just want to become your whole friend. It just takes a little more work to get it going. Okay? Let me do another example for you. Let's do number 7. So 7, we have 7/8 minus negative 1/3. All right? So here's an example where, in this case, 3 doesn't go into 8. It's not going to work there. I could think, what's the next value of 8? I have my facts for 8. I have 8, 16. 8 times 2 is 16. 8 times 3 is 24. And I go, oh, that works, because 3 times 8 is 24. So in this case, multiplying them by the same thing, by the same number, it works. So if I multiply this one by 3 over 3 to get 24, that becomes 24. 3 times 7 is 21. Over here, I multiply by 8 over 8. 3 times 8 is 24. 8 times 1 is 8. And keep the negative there. Alright, so what do I have? I have this 21 over 4, 24, sorry, minus, that minus has not gone away, negative 8 over 24. Alright, that making sense here? I just multiply the two denominators together to get a common denominator. Worked out that time. It's the smallest one anyways. We're good to go. So now, when I have subtraction, what do we say about subtraction? We want to add the opposite. So I'm going to add the opposite. Now, let's work on this. Denominators are the same, so that stays there. 21 plus 8 is 29. And I'm almost done, except that one's too large. So I can break apart 29 into what? 29 becomes 24 and a 5, because 24, 24. So it's like saying 24 over 24 plus 5 over 24. This becomes 1. So I have 1 and 5 24s. Alright, so there's lots of little details there. So today's homework is going to be one where you're like, oh, I don't want to do this. It takes time. I totally understand. But it's one of the most important ones you need to be able to do. You have to be able to work with fractions. So this is one you're going to want to work on, and then come back and check the solutions on to see how you did. Okay? There are a lot. Totally get it. We want to make sure you understand how to work with fractions because they're going to continue to come up in all your other math classes. Okay? So pause there, work on those, and see you in a few minutes. All right, here we go. Some of these are going to be easy, some a little more challenging, right? All right, number 1, pretty easy. Same denominator. We put them on the bottom, no problem. We add it up. 3 plus 3 is 6, and we're good. Simplest form, I'm going to reduce. One more step. Divide that by 2, divide that by 2, and we end up with 6 divided by 2 is 3, 8 divided by 2 is 4, and that's as small as we can get it. Number 3, same denominator, so it's alike, so we keep the denominator the same. We just add 9 plus 3. 9 plus 3 is 12, but now that one's too big. So I can break 12 up into what? I can say it's 10 plus 2. So 10 over 10 is what? 1. And then 2 over 10 is 2/10. Now careful here. You might think you're done, but I could actually reduce 2/10. Let's divide 2/10 by 2 by 2. So I end up actually with 1 and 1/5. So this one just keeps like simplifying down. I turn from improper to mix, and then I still reduce the mix down to a simplified version there. All right, number 5, same idea, same denominator, common denominator there, so we can just keep the 3 on the bottom. 2 plus 2 is 4. So this is an improper fraction once again. 4 is the same as 3 plus 1. I'm just keeping the 3 because that's my denominator. So I end up with 1 and what's left over? 1/3. Number 7. All right, different denominator, so I have to do some work here, right? So let's rewrite this one. We have 8 over 15 minus 1 over 5. And what I want to do is find a common denominator. I know that 5 has something in common with 15. If I multiply it by 3, do the same top and bottom, I'll end up with what? 3 over 15. And it's still a minus there, right? So I can kind of like ignore that for just a second. So I have 8/15 minus 3/15. Now if the denominator is the same, I'll keep that there. And I'll do 8 minus 3, which is 5. But don't stop, because I could divide the top by 5 and the bottom by 5 to simplify that to 1/3. These are all problems where there's just one more step to do. So if you had 5/15, it's right, but you want to go one more step. Number 9, common denominator. I'm going to go with 10 because if I multiply this side by 2, so 2 over 2, I end up with 10. And 2 times 3 is 6. So now I can do 6/10 minus 3/10. The denominator stays the same, so that's 10. 6 minus 3 is 3, and there's nothing else to do. Number 11. 20 and 10, not the same, but if I multiply this by 2 over 2, I end up with what? 3 times 2 is 6, 2 times 10 is 20. Now I have a common denominator. So I'm going to kind of ignore that on my paper. Common denominator says, keep it the same. Now I do 19 minus 6 is 13, and that's it. Ah, whew, nice. Not a lot of simplifying, right? Okay, the next one. This is one where it's nice to know your math facts, because I don't want to multiply it together. It's going to be way too big to deal with. But I do know that 12 times 3 equals 36. 1 times 3 is 3. And over here, 9 times 4 equals 36. And 4 times 4 is 16. So rewriting this, I actually have 16 over 36 minus 3 over 36. By finding a common denominator, the least common denominator in this case was 36. Now for the same, I keep the denominator on the bottom, and I do 16 minus 3, which is 13, and I should be done right about there. Number 15, 4 and 7, not a lot in common there. They really don't have much in common. So we would say 3/4 plus 1/7. I'm going to multiply this side by 7 over 7, this side by 4 over 4. Why? Because I'm going to get 7 to multiply that out to be 28. Oh, I should make it a little bit smaller so I have some space there. This becomes 28 over, or 7 times 3 is 21 over 28, plus 1 times 4 is 4 over 28. Now that I have a common denominator, I just add them up. 21 plus 4 is 25 over 28. Number 17, common denominator between 9 and 6. All right, in that case here, it's going to be 18. All right, so let's write this out here. If I multiply this by 2 over 2, that becomes 18. 8 times 2 is 16. Over here, it's 3 over 3. 6 times 3 is 18, and 5 times 3 is 15. So I'm going to ignore the stuff I started with. Ignore the stuff I started with, and now I have a common denominator of 18, and I have 16 minus 15, which is 1. Alright, number 19. Common denominator. 3 goes into 9 3 times. So let's multiply this side by 3. This is so nice. 3 times 3 is 9. 3 times 2 is 6. This is great so far. This becomes common denominator of 9. 7 plus 6 is 13. Alright, so 13, I need to simplify that because that's improper. So I can break that apart into 9 plus 4. So this becomes, 9 over 9 is 1. And I'm left with, check, 4 9ths. Number 21, 4 goes into there 3 times. Alright, so I can do 4 times 3 to turn that into 3 over 12. So I have 11 12ths minus, the minus stays the same, 3/12. Denominator is still 12. 11 minus 3 is 8. I can just reduce that because 4 goes into there and 4 goes into there. 4 goes in there 2 times and it goes in there 3 times. So we have 2/3 as our solution there. One final one for you to look at was this one with a variable. We plug in 5, 6. We subtract b, which is 3/8, and then we do the work. This is going to be 24 as our denominator. That's times 4. 5 times 4 is 20. Times 3. 3 times 3 is 9. So denominator stays 24. 20 minus 9 is 11. And that's our last one. And that took quite a bit of time, I know. I'm a little faster because I do it a lot, but you just want to get smooth at this and try not to make silly mistakes. Chances are I probably messed up somewhere in there because I went really fast through that. Hope that helps you. Have a great day. We'll see you next time.